Lani Paʻa, The Celestial Sphere, by Kameleo Pu'uvai, Abby, and Noah. Lani Paʻa, meaning celestial sphere or solid, is the highest space above, or Malo 12, as seen in the reading, which I thought of as like level 12, with Luna A, or the space above one's head, as level 1. Lani Paʻa is an imaginary celestial sphere in which the stars and other celestial bodies are located, and where the Earth is at the center. Due to Earth's rotation, Lani Paʻa can seem to move, causing the stars to sort of rise in the east and set in the west. Next we have Kealanui Ake Ku'uku'u, which translates to the roadway of the spider. This is a poetic name for the celestial equator. The celestial equator is an imaginary line through the middle of the celestial sphere, on the same plane as the Earth's equator, and is equidistant from both the north celestial pole and the south celestial pole. The celestial equator is divided into 24 hours, as that is how long it takes the celestial sphere to complete its rotation, meaning 1 hour would equal to 15 degrees, and each degree is equal to 4 minutes. Next is Ho'okui, which literally means joined, but in this context, it is the word for zenith. Zenith is the point directly above the observer's head, as seen in the readings in the quote, where the walls of heaven meet directly overhead. According to Kamako, also in the reading, the Ho'okui or zenith is the juncture, equidistant from the sky downward and the earth upward. Through outside research, I also came upon zenith stars, which are stars that lay directly overhead of a specific spot or area, such as Hokulea or Arcturus, which is directly over Hawaii. Next is Halavai, which means meeting, though in this context it is the word for horizon. This word actually describes the action of the horizon, as this is the spot where the sky and earth meet. As seen in the diagram, the horizon would be this line, making up the base of this half sphere. To the people at the time, it seemed that the stars and other celestial bodies seemed to emerge from puka or holes in the horizon, as seen in the quote, puka mai kala, meaning the sun emerges or appears as from a hole. Measuring the altitude of the stars from horizon helped navigators to determine their latitude.
Aloha everyone, I'm just going to talk about a couple terms real quick. So the first being zenith, which is the highest point in the atmosphere above the observer's head. So in this picture, it's pictured here. So it's the highest point in the celestial sphere. This is positioned in the direction of the gravitational pull. So in this diagram, the person or the observer would be standing right about here on Earth, obviously, and then that's kind of their straight up. On Earth, when the sun has reached zenith, it is directly overhead, and you can determine latitude and longitude from the zenith position. So you can measure the angle upwards from the equator for latitude, and then to the right or left from the Greenwich meridian to determine longitude. For a meridian, it is the imaginary line passing through zenith and the north and south celestial poles. It's perpendicular to the horizon and the equator. It's the zenith and nadir of someone's location, so nadir is the opposite of zenith. The Greenwich meridian has a longitude of 0 degrees. To determine longitude, you can use measurements east and west of the line. You can actually stand on the line in England, and it's the baseline of time for the rest of the world. So you can use it to determine longitude by measuring the degree from the north or the south poles. For declination, it's the angle of a star away from the celestial equator. This angle remains constant as the sphere rotates. The celestial equator is 0 degrees. It is essentially the distance from zenith to the equator in an angle following the celestial sphere. Declination in astronomy is comparable to geographic latitude, and you can calculate it by subtracting the zenith distance from 90 degrees. So if, say, a star was out here, say this is about 45 degrees away from zenith, that minus 90 is 45, so it would be a 45-degree declination.
This is Kamele coming at you live, your Lani Paʻa forecaster. I'm mostly here to just show you. I'm mostly here to look nice. I'm gonna basically summarize what my teammates did because they did a really good job explaining all the points we have to talk about. I really don't need to explain what I was supposed to explain because they explained it for me. So I'm just gonna take on the role of demonstration. On my broke college budget, here's our Lani Paʻa points, if you remember what it is. Celestial sphere. But we use Olelo Hawaii. So this is our Lani Paʻa. Here's our axis. And imagine there's no tilt to this thing, it's just straight. So we have, it basically just goes straight through. And then imagine our axis has a tilt. Okay? So we have a 23-degree tilt, and our axis is still coming through the top and the bottom, just like Earth. Earth has a 23.5-degree tilt. And Earth is inside the celestial sphere. See how it's like hollow? In there is all meteors and other stars and other planets and the sun, which is a star. But we're just going for the outside right now. So our axis and our tilt, right here, this top and bottom, those are our north and south celestial poles. And then east and west, yonder. This line going like this is our Keala Nui a Ke Ku'uku, which Noah talked about. If you remember what it is, bonus points. But Alanui's road, Kukulu is, Ku'uku'u is the spider, so road of the spider, and that's on a celestial sphere, okay? It just so happens to line up with Earth's equator, so that's why I was super confused for a long time, but I just got it. So if we take this off and pretend Earth is floating right in here, right in the center, and its equator lines up with celestial equator. So then we have Kukuluokalani, which is where the sky meets the ocean. So the sky of our Earth, not outside of Earth, but our atmospheres, where all of that meets the ocean in our world, okay? Halavai, which Noah talked about, is the horizon of Earth. So where we see the sun rise and set, and it sinks beneath the waves, or behind a mountain, wherever you live. That's our Halavai, our horizon, okay? And then Kumulani, I'm taking this for my interpretation, but the reading says where sky meets the earth. Lani means sky in a bunch of different ways, so we're gonna take it as sky in this emptiness meets earth. So where the base of the sky of the heavens meets our atmosphere. So that's Kumulani, not to be confused with Kealanui a Ke Ku'uku or Kukuluokalani. Where was Kukuluokalani? Is that on the Lani Paʻa or on Kahonua? If you said Kahonua, you'd be right. All right, now I'm just gonna do a quick demonstration of all the things Abby talked about. So zenith, meridian, and declination. So we'll start meridian. Meridian is the thing that goes from the northern celestial pole down to the southern celestial pole. So it crosses the, nice. So that's the meridian. And she used the example from Earth, the prime meridian, where, you know, of course, Europe set our time to revolve around them. How European of them, right? So then we also have our zenith. She used the example of 45 degrees. So wherever you're at on Earth if you're 45 degrees. In the sky, 45 degrees, you subtract 90, which it's 90 from 180. So this is 90 degrees from your 180 degree out of 360. Okay. So you subtract 45 from 90 and you get 45. So that's your zenith. That is your declination. Zenith, also called ho'oku'i, which we learned from Noah, is equidistance from the sky to the earth. So that's your ho'oku'i. And then declination is the math you get to do in astronomy. There's no extra credit. This is purely for your benefit, and mine and ours, because, you know, you learn best when you teach it. So, Mako lala Hawaii. Heaha keia. Wow. Heaha keia. Heaha keia. Ke ala nui a ke ku'u keia. Aole. Ka meridian keia. Aole. Heaha. Heaha. Ka Lani Paʻa. Ka Lani Paʻa keia. Or celestial sphere keia. Ma namuhale. Celestial sphere. Heaha keia. Ma ka celestial sphere. Heaha keia. On the celestial sphere, what is this? Halavai. Aole halavai. Meridian. Aole meridian. Heaha. Ke ala nui a ke ku'u. Ke ala nui a ke ku'u keia. Path of the spider. Road of the spider keia. Navai. I ka halavai. Where is the halavai? On the outside, on the inside, in the bathroom. Where's the halavai? On Earth. It's the horizon for the Earth, not for the Ka Lani Paʻa. It's for honua, ka honua. Okay? Nawai I ke kukulu o Ka Lani. Nawai I ke kukulu o Ka Lani. Where is the kukulu o Ka Lani? Where's the borders of the sky? It's on the Earth where sky meets the ocean. So that 3D Earth, where that sky in there meets the waters. Okay. Nawai I ka ho'oku'i. Zenith. Nawai. Where is it? Nawai I ka ho'oku'i. Keia. It's at the top. Zenith. If you can describe it to yourself, mai ka iloa. Let's see. And then Nawai ka meridian. Keia. Aole. Keia. Aole. Meridian. Ka meridian keia. Wait. North to south is the meridian. And heaha ka declination. What is declination? The degrees from where a star sits and what you're looking at to where ho'oku'i is. Star degrees subtracted from 90 where the ho'oku'i zenith is. Okay? Well, congrats you guys. Hopefully you guys understand. Mahalo nui for watching.